Hello, everybody, and welcome to Standing for Truth. I am your host, Donnie, and on Standing for Truth, we host lectures, interviews, debates, and more. And so if you enjoy this content, please make sure to hit that subscribe button. And please share around this content as the truth is so important. Now, we also strongly believe in critical thinking and engaging in dialogue with those of differing beliefs and positions. One of the many ways that we promote critical thinking is by hosting some really awesome debates. And today we have a very important debate between two very well-educated individuals. It is a privilege to have Professor David McQueen and Dr. Jason Torn here with me today for a very important and exciting debate. I should say this is the much anticipated debate on the Genesis flood because we've had it posted for a couple months, and myself included, there has been a lot of excitement pertaining to this specific exchange. So again, we are debating the Genesis flood, and gentlemen, Jason and David, thank you so much for giving us your time for tonight's important debate.
You're welcome, Donnie. Glad to be here, sir.
And I'm glad to have you both.
Yeah, great to be here.
Okay, well, what we'll do is what I like to typically do is kind of break the ice, get to know the debaters just a little bit before we get into the fun and the debate itself. So why don't we start with Jason. Jason, it's your first time on this platform. Again, I appreciate you giving us your time for this. And let's hand it over to you, a little bit about you, a little bit about your channel, and how you doing today.
Yeah, thank you very much, Donnie. Really appreciate having an opportunity to chat with everybody today, chat with David, and good to see all the other folks watching the debate.
Oh, Jason, let me just stop you there real quick, if you don't mind. In the pre-show, your audio was coming in perfect. Right now, there's kind of a delay, and it's coming in a little staticky when you talk. I'm not sure if it's the mic itself. Is that how it is for you as well, Professor McQueen, or is that just me?
Yeah, I heard static on Jason's feed there. I was careful to turn my cell phone off. Sometimes that does it with me.
Oh, yeah. It looks like Andrew in the chat was saying the audio is a little bit...
Test. Can you guys hear me? Is it still choppy? Still choppy?
Yeah, it is kind of coming in a little static.
Let me quickly leave the studio and come back in real quick.
Okay, good idea.
Is that all right? Okay.
Oh, yeah.
Actually, the last bit of what he said was clear. Was it to you, the last 5 seconds?
It did improve there a little bit, but the fact that he'll at least refresh it, I think we should be good.
Oh, okay,
and,
good.
To the audience, everybody listening, how's the audio from myself and Professor McQueen coming in? Just so we know it's not a studio issue.
Those of you in the class, just raise your hands, and we'll know that you can hear.
Okay. So it looks like it was just Jason, but he did come in good during the pre-show. So it might just be something as simple as rejoining and
while he comes back, let's see if this solves the problem. There's
test.
Jason.
Can you guys hear me? Test.
Yes. Yeah, you're coming in smooth now, Jason.
Geez. Okay. Well, I hope this doesn't. This is not a thing that's going to happen continuously. So.
We'll keep our fingers crossed. At least for now, it looks good. Your picture's coming in good, and there's no more lag. So why don't we try that again? Jason, a little bit about yourself, how you been, and also I know you have a channel, so a little bit about that as well.
Yeah. So thanks, appreciate that. Just to repeat myself, I'm glad to be here. Glad to be chatting with David on this topic. So I'm Jason Torn. I've got a PhD in natural resources with a focus on climatology and data science. I do a lot of machine learning with regards to climatology and climate effects on agriculture and health. And I have a channel, The Science Ultimatum with Jason Torn. I typically don't put a lot of content up there, but I'm trying to start to do that a little bit more. And I'm looking forward to the opportunity to talk about these topics.
Awesome. I appreciate that introduction, Dr. Jason Torn. And again, thank you so much for being here and doing this debate. It is an important topic. So over to Professor David McQueen. How are you? What's going on? A little bit about yourself.
Doing well. And Jason, I appreciate you so much. And I have an undergraduate degree in geology from the University of Tennessee and a master's in geology from the University of Michigan. Now, the reason that I have a master's and not a doctorate, even though I was a National Science Foundation graduate fellow there, is that my committee was not concerned at all about my glasses or my James Bond-like bow tie that I've untied here. They weren't concerned about that, but they were concerned that I was a Darwin doubter. Much of what you hear me say tonight, Jason, I have to tip a hat to the professors at Michigan. So don't hear sour grapes in this. It's simply a matter of fact that this topic is controversial. Thank you, Donnie.
My pleasure. Thank you, Professor McQueen and Dr. Jason Torn, for your introductions. Now, for the audience sake, today we are debating the Genesis flood, with Professor McQueen taking the affirmative. So you could think of it as, does the scientific evidence support a worldwide flood as read about in Genesis? And for your sake as well, I do want to go over kind of the format for tonight. And it's going to be formal. And we're going to keep it professional and, of course, as equally timed as possible. We're going to be starting off with 15-minute opening statements. David is going to kick us off there. Then we're going to have 10-minute uninterrupted rebuttals. Then we're going to have a 5-minute break because that'll be about the hour mark. And during the break, I'll go over some reminders, some announcements, and I'll finish gathering some audience questions. Then we're going to have a 5-minute closing statement. And then, again, this is where we get you guys involved. As always, we're going to have an audience Q&A. So just please make sure you're tagging me at Standing For Truth, and that way I won't miss them. Okay, let's get right into the debate itself. And Professor David McQueen, we're going to hand it over to you for a 15-minute opening statement. And I believe you're handling your own timing, David?
Yes, I have my secret clock here, so I'm ready to go. But I do need a reminder from you when I get close to 15.
Definitely.
One of the words that I want the class, as I think of it for this debate, to look up is a word that my mentor, Dr. Henry Morris, taught me years ago. There's an ironic way to approach a debate like this, and there is an argumentative or combative way to approach a debate like this. So I want to begin complimenting Dr. Torn for his work in climatology and natural resources. And as the ironic part, once he provides Donnie his mailing address, I want to send you, Jason, a autographed and inscribed copy of my book that talks about minerals, mineralogy, and minerals in the Bible. So I want to make sure that you get a copy of that. Later on over the weekend, send Donnie the address you want that sent to. So there is that part of the debate. Now let's get to the argumentative part. Behind me, you'll see a chronology of my family, and we're not going to go into all of that tonight. The only thing that I want to bring up at the very beginning is the interesting fact that 139 years ago, my grandfather, H.H. McQueen, was born. Now, 1883 should ring a bell with many of you. Turns out that was the year after Darwin died. So let's go back. I was born in 52, my dad in 1914, my grandfather in 1883. So Darwin is only 3 generations away from me. So this argument about the Great Flood and whether the Great Flood can explain fossils or whether evolution explains fossils, it's something that goes back, in my case, and it was shocking to me actually, to realize that my grandfather was born the year after Darwin died. My argument is going to be around 5 minutes on these three proves, I believe, that the Great Flood happened as is described in the Bible. Now, it's important to me that at the very outset, I comment that I make no apology at all for the Bible as a historical document. And so as the 2 hours goes on, I'll talk more about that point. But I think that when we talk about different sources of references in this argument that Jason and I are going to be part of, I will be bringing up the Bible in our discussion time and throughout the next hour and a half. My three arguments for the worldwide flood is the prevalence of blanket sediments worldwide and through what Jason, I anticipate, will call the geologic column. The second argument will be the Grand Canyon. In the mid-1980s, I hiked the Grand Canyon 5 times in 4 years between 1983 and 1987. And this is the code I've used over the years as I've studied the canyon, GRCA. The deposition of rocks in the Grand Canyon and their subsequent erosion, I think, is best explained by a worldwide flood. At this juncture, it's very important for me to reiterate the fact that I got my first job as a geologist in 1969. And so for well over 50 years now, I have worked as a geologist as I've gotten my degrees and so forth and gone through working for the United States Geological Survey and so forth. But in all those years, I have come to the viewpoint that the Earth and the universe are young, 6,000 to 10,000 years. And I'll go ahead for argument's sake tonight with Jason. I'll use a 6,000-year-old Earth and a worldwide flood that lasted a literal year, catastrophic plate tectonics, catastrophic sedimentation, during a 12-month period, as talked about in the Bible in Genesis 6, 7, and 8. My third area of argument is going to be the prevalence of limestones worldwide in these very persistent facies. And I'm going to focus and challenge my opponent regarding the chemistry of limestones. I know with your background, Jason, in agriculture and natural resources, you've probably been in a lot of chemistry classes. And so these arguments, I hope, will ring a bell with you. Let's start with the truth of blanket sediments. I would recommend that if you don't have this book by Derek Auger, I've got the second edition here that I got years ago, that you should get this book. It's The Nature of the Stratigraphical Record. Now, Auger, or Agar, however you pronounce his name, is not a creationist. He has no biblical bone to pick the way I do. But in his book, he very clearly makes this point that the rocks he's seen and the rocks I've seen worldwide blanket continental size areas. Now, his first sentence in the first paragraph of the first chapter, it's called The Persistence of Facies, is a very good argument, and I'll start with it. He's going to be talking about the Upper Cretaceous chalks that he's seen in his life. The White Cliffs of Dover, for example, is an example of this. And then he said this: in 1957, I had the good fortune to visit the geologically exciting country of Turkey. and he looked at some of the Mesozoic rocks and faunas. And one of his Turkish friends said, let's go look at some Upper Cretaceous sediments on the Black Sea. This is south of Ukraine, across the Black Sea, down in Turkey. And he read the literature on it. This is Derek Auger did. And these were described as white limestones with chert nodules and a strange sounding list of fossils. So he finally gets out in the field and puts a rock hammer on these rocks. And he says, I was astounded. What I in fact saw was the familiar white chalk of Northwest Europe with black flints and fossils in it that I had known from the White Cliffs of Dover, and also the rolling plateaus in France, quarries I'd seen in southern Sweden, and cliffs in eastern Denmark. And that's what got him thinking about this argument that the correct way to view stratigraphy is as a group of blanket sediments. He's very famous about his comment in drawing an analogy between sedimentary rocks and the life of a soldier. His point, which he makes very clearly, is he said that sedimentary rocks are very much like the life of a soldier. Long periods of boredom followed by brief episodes of catastrophic, dangerous things. As we go through this discussion, you need to realize that this persistent sediments is something I have seen in my geologic career worldwide, certainly starting at the Grand Canyon with the Tapeats sandstone and what are called the lower Cambrian rocks there in the canyon. And then where I've gone to school in Tennessee, I've seen the equivalent rocks there. So I have seen these rocks very persistent over North America, what Dr. Clary calls the Salk sequence. Now, my second point about the Grand Canyon is that when we look at the blanket sediments that are exposed in the Grand Canyon, but then go to the northeast, and then as we go up from the canyon and get on to the what Jason will probably call the Mesozoic and the Cenozoic rocks, they're very extensive. And so here, these washcloths can be an example of blanket sediments. And so my argument is that when you look at the Grand Canyon and you see the red Tapeats sandstone at the base, and then you work your way up the canyon to the Coconino sandstone that is near the top, and then the Kaibab, that these sediments are laid down in broad blankets over much of the area around the Grand Canyon. That's exactly what would be predicted by a worldwide flood. Furthermore, once we get past the deposition of these rocks, the erosion of the rocks provide another fascinating argument for the worldwide flood. For the last 2 years, I have worked with Dr. Steve Austin and Ed Hollerud, and the three of us have submitted a paper, and it's been published in the Answers Research Journal. At the end, Donnie will put the reference exactly to this so you can find it, Jason, for future reference. And it talks about remembering spillover erosion for the Grand Canyon. Now, it's a very long paper, but the argument is that the Grand Canyon is one of the best examples of hydraulic erosion. And the best way to explain it is that toward the end of the flood, a huge lake was impounded to the northeast of the Grand Canyon. That burst, and then the erosion that we see. In all of my trips to the Grand Canyon, going back to 1976, I'm seeing an antique landscape. I compare pictures I took in the 70s with pictures that John Wesley Powell took in the 1800s, and it looks the same. So whatever erosive event carved the Grand Canyon is certainly not going on today. My final point is the point about limestones. Many times on this channel, those of us that have an interest in defending the worldwide flood have been challenged, and they say, oh, okay, McQueen, you might be able to explain some sandstone like the Coconino at the top of the Grand Canyon, but surely you can't explain the limestones that are found there. And I say, as they do in French, au contraire. When we look here, we see a limestone. Now, this is a type of limestone found in East Tennessee. These are stromatolitic limestones in the middle Ordovician Knox group. And this is very porous, but it's also fossiliferous in the sense that it's a stromatolite.
2 minutes.
Oh, say it again.
Oh, 2 minutes.
Thank you. I need that. So this is not what a micrite looks like. A micrite, to your screen, would look a bit like the James Bond bow tie. You know, after the race through the streets, he always unties this thing. It's more of a dove gray limestone. My argument is that using something as simple as antacid tablets and water and salt and heat, we can modify the pH, the electrical properties of water, the EH. We can modify the amount of salt in the water, the temperature of the water, and the amount of calcium carbonate in the water. And combining all these things together, we can directly precipitate limestones such as are seen in the Bahamas. And so I think that that's a good starting point, Jason. That would be my first three arguments.
Okay, perfect timing there, Professor McQueen. I appreciate that opening statement, 15 minutes. And now we're going to hand it over to Dr. Jason Torn for his 15-minute opening statement. And if you need to share some slides, Jason, just let me know.
Yeah, I'm going to share my screen right now.
Looks good. It's up on screen.
Okay, so let's hold on. Let me start my time so I can track it.
I'm getting my notepad out, Jason, so I can make notes here on what you say.
Okay, great. All right. Thanks, everybody. So appreciate David and Donnie for having me today, and I hope we can have a productive discussion. Just real quickly, there's a bit.ly link on every slide. That's where this presentation, all of the papers I'll reference, and a publication list, so folks can look at those if they would like. So my presentation will focus on two main hypotheses. One is the topic of the Earth's age. My premise is the Earth is 4.5 billion years old based on a plethora of research, which strongly suggests lengthy gradual processes in the geologic rock record, which I see, and I think that a scientific consensus would support, is antithetical to a global flood theory. So I'm going to touch upon this first aspect, and then I'm going to touch upon the second aspect. Again, real briefly, my proposition are the Earth is 4.5 billion years old, and that slow incremental processes, not catastrophicism, are the predominant mechanisms for what we see in the rock record. Doesn't mean that there aren't catastrophic outcomes throughout time, but that the predominant mechanisms are slow incremental processes. And the above statements do not conflict with religiosity or beliefs in a god or gods. I think that you can believe in a god and still believe the Earth is old, and that Noah's flood is more of a story that may be associated with local flood outcomes. I'm going to real briefly just mention that there are many flood myths throughout time in a variety of differing cultures. That historians have noted the issues of more localized flood events that may be some of the reasons why these stories have come about. And I would also note that religious faith, I think, plays a role in why some of these myths have come to be and why they may contradict more modern scientific outcomes. Just a real brief quote by David Montgomery, who wrote a great book called The Rocks Don't Lie. He's a professor at University of Washington. If the world is old, it allows time not only for mountains to rise and erode, but more problematically for evolution to work. And in defending an interpretation of God's word contradicted by geological evidence, creationists abandon a long-standing Christian precept or belief that the rocks don't lie. And I think that that's a very important aspect to think about in terms of why the flood story is even being bantered about, as opposed to maybe taking a different approach of what does the data show us? What are the hypotheses? Let's evaluate those hypotheses. So the two main types of methodologies I see are, one, and I don't mean to sound dismissive at all, but I think that what's happened is we have religious texts which propose an outcome that Noah's flood occurred, that scientific evidence is then pre-selected to support that position, which in turn supports a biased viewpoint, as opposed to saying, let's take the data and evidence that we see, let's form hypotheses, let's evaluate those hypotheses, let's iterate over that. And as such, a theory can be formed, which may represent what we see in the rock record, in the world as a whole. And even more specifically, this approach, when incorporated into an integrated model, so across many disciplines, is even more powerful. So if we have many disciplines that have independent theories that all corroborate one another, that is a very powerful view of what may be a correct theory. Doesn't mean that it's absolutely correct, but it means that we may have a reasonable cause to think that those theories reflect actually what has happened. So I'm going to just briefly touch upon this first topic of what evidence do we see for the Earth being old, or what evidence do we see that would support a young Earth? I think I'm not going to spend a lot of time on this, but there's extensive history of geologists throughout time exploring these ideas of a global flood, of flood geology, and building upon evidence and research that has been done to come to the conclusion that the Earth and the processes that we see are due to long periods of time that are creating the rock record, as opposed to more catastrophic events. And I'm not going to go into all of these, but certainly Hutton and Lyell, in terms of their work supporting the issues of deep time and uniformitarianism, in the early 1900s with radiometric dating, has been developed over 100 years and is an established science. The aspects of continental drift and plate tectonics, and then leading up to Whitcomb and Morris, which I know David has been influenced by through his background with regards to creationism and a flood. My only point is that these issues have been bantered about for hundreds of years. We haven't just come to the conclusion that the Earth is 4.5 billion years old very rapidly. It has been a developing theory across many disciplines. So these are a variety of different disciplines that support an old Earth. And I'm going to touch upon some of these: plate tectonics, carbonates, paleogeography. But there are a variety of topics that all corroborate one another. Plate tectonics, the theory that the Earth's lithosphere contains tectonic plates that have been slowly moving over billions of years. An established research area for the last 60, 70 years based on continental drift from Wegener's work, motivated by the mantle convection that's occurring. The citations I'm listing here support these positions and can be looked at in the Dropbox or the Google Drive that I've noted. That tectonic plates are made up of the crust and the lithosphere. I think most people know this. Thinnest at the oceanic rifts, thickest at the continents. That there are a variety of differing movements or speed of movements for different plates. But a key point is we know that the rate of these plates based on magnetic stripping and magnetic the pole reversals are roughly what we expect, 5 centimeters to 15 centimeters a year. And we have a considerable amount of research that has explored these areas, including evaluating magnetic anomalies and looking at plate movements through modeling to estimate where they moved over time. And needless to say, an extensive amount of research. Seaton et al., Maria Seaton, she's done a lot of work in magnetic anomalies. Yoshido and Hamano, they've done a lot of work and have modeled out the movements around the India plate. Next, I'll just briefly talk about radiometric dating, a very established research area based on parent and daughter isotopes. There are a multitude of differing radiometric techniques, the radiocarbon techniques, potassium argon, rubidium strontium. All of them differ based on the time period of their radioactive decay. There is a lot of discussion on these topics about the confidence intervals with regards to the differing radiometric dating. I would just note that oftentimes many different radiometric dating techniques are used simultaneously to be able to come to conclusions on estimates of dates. And that multiple dating methods, along with using many, many samples, allows us to get a pretty good estimate in terms of dating of particular rock strata. So I think that it's a fairly well-established science, and I think that if you're going to say that the Earth is considerably young, that you're going to have to address these issues. And I'm not going to spend a lot of time on this, but there are certainly several books that support the radiometric dating perspective. And given my time, I'm not going to go into a lot of this. Ice cores, another area that we use extensively to evaluate climate, that we use dust and pollen in ice cores to evaluate ages. We use kind of a seasonal structure of looking at the layers of ice cores to be able to evaluate dates. Pettit et al. Has done some excellent work in this area. I've got the paper in my list, and discusses a 4,000-year-old dating period. So ice cores are another area that we know are supportive for that. Paleogeography, another area that is interacted or very closely associated with plate tectonics. Lots of good research in this area. Dendrochronology, another area very well supported that is associated and can be connected with stalagmite cycling. So yet another area that goes back further than 6,000 years. All of these areas combined support an old Earth. So now I'm going to talk briefly about the specific flood issues. And I've just got several that I'm going to touch upon. The time problem, I've already discussed this. The water issue, the amount of water needed. Fossil stratification, limestone, deformation, reefs and varves. These are just a few that suggest that there are problems with a global flood in the formation of some of these items. The water problem. How much water do we have on the planet? If we just take the oceans and fresh water and we assume those are in place 4,500 years ago, we're left with groundwater and ice caps. If we don't even consider groundwater, because I think that there are problems in thinking about how water is going to be forced out from the deep and due to hydraulic pressures, not retract some of that water. I think that's a problem. We're essentially just generally left with ice caps. And we know that right now, if you melted all the ice caps, you only rise the seas around 60 or 70 meters. That's a problem. So I think that there's an issue with where's all this water going to come from? The fossil problem. So how do we explain the vast numbers of fossils that we see in particular strata, like the Karoo group in Africa? I think that's a problem for flood geology. Fossil stratification, a major problem. How do we see mammoths and mastodons at a high level in the rock record and smaller fossils in a lower level of the rock record? That's a problem, I think. Cuvier's work in the 1800s brought to light some of these issues that fossils are not the same age. And he's the father of invertebrate paleontology. Cuvier himself, 150 years came to some of these conclusions. Limestone. David talked a little bit about this. I think this is an interesting subject. I think it's very difficult to say that we have formations of limestones due to microorganisms, hundreds of feet of limestone. How did so much limestone form? How can a flood model explain so much limestone? The calcium carbonate precipitations would have to be huge. And remember, calcium carbonate, as well as aragonite and other types of limestones, require a very specific type of temperature, non-turbidity, low pressure. It requires a very specific type of environment to have so much limestone. And the rates, even with optimum situations, cannot really occur in the time periods that we're talking about. So I think that this is an important topic to talk about. Deformation, another topic. How is it possible that the Grand Canyon could have been softly deformed? The actual weight of the Grand Canyon would have collapsed upon itself. David talked about blanket sediments. How is it that limestone and sandstone are both there in the Grand Canyon? They form under completely different regimes. I think that the sandstones in the Coconut sandstones have been shown to be aeolian in formation. So there are a lot of research that would suggest that it's not water driven. Reefs, another problem. How did reefs form so rapidly? So I think that that's an issue. Varves.
1 minute.
How did so many varves form? We know that varves form in deep lakes. They require very calm environments. We see sometimes at some places 200,000 varves. How did so many varves form in such a short period of time? I think that these are problems that have to be addressed if you're going to suggest a global flood. And then my last slide, I think that the main takeaway is when we integrate all of these areas together, they all point to a current Earth systems model that is much older and not supporting a global flood theory. I think that in order for a global flood theory to be considered, there has to be a proposed model that can integrate all of those areas and support that position. And I will stop there. Thank you.
Perfect timing from the both of you. I appreciate it, Jason and David. That concludes the 15-minute opening statements, clear, concise, and great job to the both of you. So we're going to hand it now over to Professor McQueen for a 10-minute uninterrupted rebuttal. And I'll give you both gentlemen a 1-minute warning when you reach the 9-minute mark. So, David?
I've set my stopwatch for the 10 minutes, so I'm ready here. Well, Jason, you certainly have introduced a lot of things that we can talk about for the next hour. Let me focus on some things that I made notes up here. A very interesting point you made from the book, Do the Rocks Lie? I would suggest that the rocks do not lie. And when we look at the correct pronunciation, by the way, of that sandstone in the canyon is the Coconino sandstone near the top. When you look at that sandstone, which is very thick, 30 meters, 100 feet thick, and it's extensive over much of the American Southwest, we have to take the Aeolian model that you suggested is a very common interpretation of it, and say, wait. If we go to the beach down in the Caribbean, we go to the Florida, Alabama line and take my grandchildren out to see the beach. The beach has got an undulating surface. The idea that this beach could have progressed in the past across much of the American Southwest with a knife edge contact between the sedimentary layers, the coconino being the yellow here and the ones underneath. It's not a good model, and I think you're wrong on that point. So that's a rebuttal. Your point's very well taken, that we have to gather data and from that data develop a theory. I would suggest that if you look at some of the books that have been published in the last few years, this is Dr. Andrew Snelling's second volume of something called Earth's Catastrophic Past. And when you look at these kind of books, I think you'll see that the theory of flood geology ties in quite nicely to the history of what you said. And I think you misinterpreted the history, misunderstood the history. On page 477, in the 62nd chapter of this man's big book, Snelling says this: as noted earlier, by the end of the 17th century, 1600s, and throughout the 18th century, the 1700s, it was generally accepted, almost without question, by scientists in the Western world that not only had the biblical flood been global, but it was a key element of the biblical framework of Earth history. So the only argument that you can make, Jason, that is a legitimate argument, is that I'm following a several hundred-year-old view of the Earth. Some would say going all the way back to the rabbis 2,000 years before Christ. So it is true that it's not modern, but it's also true that that doesn't mean it's not accurate. One of the fallacies I think you've fallen into, Jason, that I want you to address as our time goes on is, I think you can see it here if I move my computer a bit. You've appealed to authority. You said, oh, the Earth must be old because Dalrymple and all the rest believe it is old. Well, it turns out if you go back to Lyell and Hutton and look at the earthquake change that they brought by their work, a lot of their work was read by Darwin. Darwin was very, very much influenced by these two men. And you simply cannot argue that the Earth must be old because most of the professors that you have had in your PhD program, all the professors I had at Tennessee and Michigan, believe that the Earth is old. It reminds me of an old joke by none other than Abraham Lincoln. Abraham Lincoln and Charles Darwin were born the same year. A very interesting bit of history there. And Lincoln was given a lecture once, and he said, I've got a dog, and I want to call my dog's tail his fifth leg. And the audience applauded. And so Lincoln looked at the audience and said, wait, just because I call a dog's tail a leg doesn't make it a leg, does it? So you can't really appeal to authority. Now, I notice that some of this is in the way of my name there, so I'll move it so you can see it better. I was a lab assistant in the mid-'70s for Bob Gentry. I was privileged to work at Oak Ridge National Labs in Oak Ridge, Tennessee, and work with Gentry on his radioactive halo work. As we'll point out as we go on in the debate, Gentry's work clearly shows that the radiometric decay rate has not been constant with time, as evidenced by what geologists call pleochroic halos, or what he calls radioactive halos. And let me use one of my favorite examples, and this is something that I learned from Bob Gentry all those years ago, about how you can envision these things. Later on, I'm going to drop Alka-Seltzer in this, and that will be how I'll illustrate that. I'll save that for later on. Let me go on with my rebuttal. You bring up carbonates as one of your touchstones for why a worldwide flood and a young Earth could not be true. Well, the counter argument that I would give to that is that you said, in your presentation, that calcium carbonate, the calcite of limestone, if it was to be precipitated during the worldwide flood, it would be a huge precipitation. We'll put the White Cliffs of Dover to one side for a moment, since that's got fossils in it, made of fossils. But let's look at the limestones in the Grand Canyon, the limestones in the Southern Appalachians called the Knox Group. These limestones are called micrite. They're dove gray limestones. You and I, Jason, can take Donnie to thank him for his help. We can take him to the Bahamas, and we can go to Andros Island, and we'll pull our shoes off and actually walk out in Andros Island, out into the water, where there are micrite muds forming today. Well, there are micrite muds there, but they're not limestones being formed. Why? The pH, the temperature, the salinity, the partial pressure of CO2 in the atmosphere, the amount of dissolved calcium and dissolved carbonate in the water. You get a whole kinds of common things that we associate with carbonate, like ordinary baking soda is sodium bicarbonate. Well, that bicarbonate percentage in the ocean is something that's a variable. And you made the argument that you have to have data to support a theory. So I would argue that if you look at the various geochemical characteristics of the ocean of Noah's day, it's an adequate way to explain how Derek Auger could find in the White Cliffs of Dover in France, on the southern coast of, the southern part of the Black Sea, the northern coast of Turkey. How come he found charts that are blanket over the whole region? It looks like catastrophic sedimentation to me. It looks like Lyell and Hutton were missing a fundamental point.
1 minute.
How much time do I have?
You got 1 minute, David.
1 minute. It's important to realize that creationists go on to discover very interesting things. Like, I was going through Ms. McQueen's cabinet, and I found the primordial soup that you attempt to explain. It was chicken noodles. We didn't evolve from amoeba to man. It's actually from chickens. But this is primordial soup. So one of my challenges to you as our time goes on is explain to me the geochemistry, the biology, if you will, of going from amoeba to man in that Precambrian environment. Thank you, Donnie.
Okay, that concludes Professor David McQueen's 10-minute rebuttal. I appreciate that. Great debate so far. Time is flying by. And to the audience, I appreciate the questions that are flying in. Okay, we're going to now hand it over to Dr. Jason Torn for his 10-minute rebuttal. Jason, whenever you're ready, the floor is yours.
Okay, great. Thanks, David. Thanks for that rebuttal. So I think when you talked in your initial discussion, you mentioned blanket sediments. You mentioned the Grand Canyon in terms of deposition or erosion. You mentioned limestones. So I'm going to try to address those initially. Blanket sediments. I mean, we see huge amounts of sediments, miles of sediments throughout the world. We see sediments on top of erosional or on tops of unconformities. We see a variety of differing sedimentary processes around the world. So while this term like blanket sediment, which I'm not sure how that is relevant in this situation, the question is, what are the mechanisms that we see that could have produced that sediment? And I know you mentioned in your rebuttal the topic of an appeal to an authority. I'm appealing to the 99% of research that suggests the items that I'm mentioning. So if you want to say that's an appeal to an authority, I think we all are standing on the shoulders of giants. I think that it's very reasonable to say, what are the past researchers indicating? I'm not saying to take everything they say with absolute certainty. I'm saying that we take that information, evaluate it, and assess the likelihood of those positions. I think it's very reasonable to look at the wide plethora of research that suggests that sedimentary processes have a variety of mechanisms for formations, and we have aeolian processes. We have catastrophic processes. You mentioned the Grand Canyon. I certainly acknowledge that the Grand Canyon has some catastrophic processes that have occurred, but I think you've yet to explain the how we can see such differing layers within the Grand Canyon and how those formed in such different ways. I think that's a very difficult thing to address. And if in order to address that, you either have to point to research that has been done or point to your own research. So again, I would note I've listed my publications that I've been referencing. And if you have publications, like actual peer-reviewed publications that you would cite, that would be great. But if they're not peer-reviewed, then I consider those a lesser grade of evaluation. They haven't been reviewed by other experts in the area. I'm glad that you mentioned about the age of the Earth. Let me see my notes. Well, you talked about hydraulic erosion with the Grand Canyon. I acknowledge certain catastrophic events with regards to that. Limestones. I think that's an important discussion that we can maybe have a conversation about this in the open discussion. I think there's a lot of research that suggests that it takes a very optimum type of temperature and pressure and non-turbid environments to be able to produce so much limestone. And it doesn't seem that a global flood would create such a calm, low pressure, warm event. It doesn't seem like that would be the particular situation that we would be seeing. Limestones require for creation. They don't require turbid environments. And you talked about radiometric dating too, as well. What I would suggest is if you have research that would suggest that there is variations in terms of decay rates, I would love to see those papers. But I think that those papers don't exist. If they do, I would love to see them. So I guess I'll just end on this, and I'm kind of making my response fairly brief. The issues of an appeal to an authority, I think, are what you do when you actually don't have the evidence to support your position. That if you don't have the evidence, that you say you're just pointing to what experts say. But if 99% of the experts are pointing to these positions, I think it's disingenuous to say, we're just going to say that's an appeal to an authority. You're going to have to provide then your own research that would counter that. And I would say an extensive amount of research, because I'm talking about thousands and thousands and thousands of publications that support these positions. In order to refute that, you're going to have to come up with more than just one paper that is in a non-peer-reviewed journal or something that somebody wrote in a book. You're going to have to either present that research, and what I would say is not present it on YouTube, but present it to a journal. So if you've got research in this area that refutes that topic, it would be earth-shattering. you'd win the Nobel Prize if you had research that suggests that radiometric dating has changed radically in the past. I would publish that paper. And then I think that would be the first step in supporting these positions. But until such a time, I think it's difficult to make those positions. And so I'm looking forward to having an open discussion on these topics.
Awesome. Thank you for that 10-minute rebuttal there, Dr. Torn. And that concludes the opening statements and the rebuttals. What we're going to do, gents, before we get into the typically the audience's favorite portion of a debate, the cross-exam or the discussion, we're going to take a quick 5-minute break. Professor McQueen, if you want to get a coffee, Dr. Torn, if you wanted to stretch a little bit, something like that. We're going to take just a 5-minute break. I'll go over some reminders in the meantime. David, I can drop your feed for the 5 minutes.
Yeah, would you please?
Yeah. Okay. If you're just going to stick, there we go. So it's just me for now. Yeah, you're all good. 5 minutes. Okay. Take your time. Well-deserved breaks for these debaters. Clearly, Dr. Torn and Professor David McQueen here have done a lot of preparation for this sophisticated debate. I'm thoroughly enjoying it already, and there are a ton of fantastic points to discuss for the discussion period. I've also got audience questions. So we will have some audience questions. What I'll probably do is pick 2 questions for each debater, because we do have a cap on the agreed upon time for this debate, which is 2 hours. So we're about to hit the hour mark. We have an hour left where we are going to fit an open discussion, a closing statement, and as I've put it, a few audience questions. So during this break, I may as well go over a few reminders. And again, thank you, everybody, for being here for this important debate. So we've had a ton of debates. We actually just had a huge debate last night. So if you have not yet seen it, it was between Dr. Dino and Snake Was Right. That was a ton of fun. We had about 400 people in the chat. It's getting a lot of good feedback. So if you haven't seen that, please do check it out. And next week, we've also got the big rematch between Dr. Dino and Wade the Wizard. And this is all for our Evolution Debate Challenge series. So the first week of May, this is a debate that a lot of people have wanted to see for a long time. Ian Chen and Kent. So they'll be debating, is there reasonable evidence for evolution? Now, as you know, we like to kind of mix it up on this channel when it comes to debate topics. So we also have quite a few theology and soteriology related debates coming up as well. So the first week of May, we've got a debate between Reverend John Crawford and Pastor J.D. Martin. They will be debating free grace or lordship. What is true biblical salvation? That should be fun. And June 9th, huge debate. This is very exciting. 2 very well-studied, well-educated, and scholarly minds, Robert Wilkin and Robert Sungenis. So showdown of the Roberts here. Both of these gents have written extensively on this topic. They've engaged extensively in debate on this topic. So this will have to do with soteriology, the great salvation debate. Is salvation by faith alone or faith plus works? And this debate will have a main focus in terms of its thesis on Romans 2:13. So make sure you're here for that one. That's going to be a huge one, guys. And at the end of the month, we've got Matt Slick, who will be back here for a debate on the Trinity. Matt Slick's been here about 6 times before, maybe 7. And he's a fantastic apologist, and he's going to be debating Otis Lewis. So they're going to be debating the Trinity. Does the Bible teach the doctrine of the Trinity? And I believe that's going to be at 8 o'clock on the 22nd or 23rd. So if you're not yet subscribed, but you love this content, you love the debates, the interviews, the lectures, the conferences, please make sure to hit the subscribe button, share around this content, and also check the event section where you can have all of these listed, as that is really just a snapshot of the debates and events that we have for you in the future. as we kind of wind down here in the last couple minutes, what I'll say is we have some solid presentations and future conferences for 2022 in the works. And so if you'd like to kind of support what we're doing, you can check us out on our website and also on Patreon. Jason, I got to say that tea looks good, and you're tempting me to go upstairs and make one as well. That's good. That's the better choice than coffee, I would probably say.
I stopped drinking caffeine. I don't drink caffeine. I just drink tea or decaf because I'm already too amped up. I don't need to be any more amped up than what I am.
Right.
So.
You've got natural energy and natural caffeine flowing through your veins.
Exactly. That's exactly right.
Which means you probably sleep good at night and wake up refreshed. So that's good.
Hey, get 8 hours of sleep, kids. That's the key. Don't skimp on your sleep.
Yeah. 8 hours and reduced intake of coffee. Those are two probably really good recommendations, even for myself. So,
hey, I just want to mention I'm not looking at the YouTube chat, so I have no idea what's going on there. But I just want to say to everybody on the channel, I respect people's religious views. I respect your views with regards to creationism. I think that it's important to have these discussions. It may be that David has some positions that I'm like, hey, that's an interesting position. I don't know if I necessarily have a response to that. So I just want to say, don't hassle me in the chat, guys. I know that you may disagree on some topics, but I respect people's perspectives.
I appreciate
here's
that.
my
Jason.
coffee as a competitor with the tea. So
that's great.
I'm ready.
Coffee versus tea. That's the second half of this debate.
That's funny. That is funny.
Well, I appreciate what you just said, Jason. Nothing but good feedback and good comments in the live chat. This is a very intellectual and sophisticated debate. You guys are great. So let's get right into it. We're going to get into the discussion now. And this is going to be about 25 to 30 minutes. I do want to make sure we still have time for a couple audience questions. So I'll monitor the discussion as needed. I think this will be fairly easy to moderate. Jason just ended with his rebuttal. And therefore, why don't we hand it to Professor McQueen, where you can start off leading the way. First question, first point. Go ahead.
Sure.
So I'm going to present something for 5 minutes and let Jason respond for 5 minutes. Is that the idea?
No. It's going to be more of a free-flowing dialogue now.
Oh, good.
So
good.
Just the question after question type thing.
Yeah.
Okay.
Yeah. Just have a conversation on the topic.
Let me bring up a rebuttal. Bob Gentry put all of his papers in a book called Creation's Tiny Mystery, and you've challenged in a very appropriate way, was Gentry's work peer-reviewed? Well, it turns out it was in science and in nature. And so let me flip to one of his papers. This is one that I actually helped him edit. I didn't provide the kind of expertise that he had because I was in my undergraduate days at Tennessee. But here's a reference for you, Jason. This is Science Magazine, 5 April 1974. And his paper was called Radio Halos in Radio Chronological and Cosmological Perspective. Now, I want to read a certain footnote that I have discussed extensively, and I want to get your reaction to it. This is from a peer-reviewed journal, Science, and
from Science Magazine, right?
Yeah, the peer-reviewed Science, like Science and Nature.
Yeah, well, there's
American
Science.
Association.
Okay, go ahead.
What's it called? AAAS, is it? American Association for the Advancement of Science.
What can you give me what's the title again, just so I can look at it? Can you read the title?
Okay, the title is Radio Halos.
Okay.
In a radio chronological and cosmological perspective. This is 1974, volume 184, And I'm going to be reading to you from, I guess, the final page, which will be 66. Okay, let me go ahead and read this as a challenge to you. Gentry, well, let me get some background for the audience. Radioactive halos are zones of discoloration in micas and fluorites. This happens to be a polonium halo. Now, Jason, if you look it up, polonium, the various isotopes, polonium-214, 218, and so forth, have got different half-lives, but they're very brief. Most of them are very brief half-lives. But at any rate, the diameter of this zone of discoloration is proportional to the radioactive decay rate, lambda. Now, we won't go into all the physics and everything because I want you to respond to this, but let me just read a part of this. He said, he goes through the differential equations, which I'll spare you them for d lambda over lambda, but he draws his conclusion. This is footnote 16. If the difference between the if the difference between the halo radius and the coloration band at 4 MeV is real, then the delta R is minus 0.4 microns, and d delta over delta, that's the radioactive decay rate, varies as much as 35%. But if you take a more conservative view, the halos furnish no proof for the constancy of lambda. Now, this went through peer review. Dalrymple is one of the ones that you referenced that has critiqued this, but I think he's wrong.
I can't find the paper.
Well, it's there, my friend. You could.
It's okay. That's fine. Maybe somebody can.
At the end of the time, I'll have Donnie put the paper on the references list. But trust me, there's one from Science and one from Nature. So my only point, my friend, is that your argument that no creationist has ever been peer reviewed is incorrect.
Well, I'm not saying that no creationist has ever been peer reviewed. Like Baumgartner's got some work that has been peer reviewed. Fair enough. There are people that have been peer reviewed. But if we looked at the percentage of folks that have, first of all, you could be a creationist and have peer reviewed work that doesn't necessarily dispute actual scientific outcomes or current scientific research. You could, you're like, if you had a paper that was a creationist and said, I propose that the earth is 6,000 years old, and I'd like to see a paper that suggests that. But even if one person has a paper that says, I think that radioactive decay has some variation, the way science works is we look at the outcomes of science over many, many papers. We look at what the consensus says. That doesn't mean that somebody can't come along and say, I have revolutionary research that changes the paradigm of how we think about a particular scientific area. That happens. But what I would suggest is that the way that happens is somebody publishes work, other people verify it, then more people publish on that work, it gets verified, and then over a number of years, minds change on what a theory is. So why hasn't there been that change with this in this area?
You raise a very important point, but as I argue with you, you have challenged that there's no peer-reviewed evidence that there might be a problem with one of the three fundamental assumptions of all radiometric dating, and that is that the radioactive decay rate of uranium or polonium or whatever, uranium, thorium, the radioactive decay rate has been constant. Gentry's work in the 70s clearly shows that what geologists look at, and that's the presence of pleochroic halos throughout the Cambrian through Cenozoic, presents an argument. So that's my only point. You're wrong in saying that there aren't papers out there, a number of papers that deal with this issue.
How many?
Go ahead.
How many? Well, before you go on, I just want to say, how many papers do you think there are that refute this? I mean, you don't have to give me an exact number, but do you think there's
well,
10,
I'm sure,
20, 30?
See, I'm sure that Dalrymple and those that have a vested interest. See, Dalrymple earns his living by radiometric dating. And so he's got a vested interest in people continuing to send samples to him for uranium, thorium, and
Okay.
uranium lead dating. So, but don't miss my point here.
Okay.
I still believe that you're committing a logical fallacy. Now, it is not true.
An appeal to an authority?
For an appeal to authority.
An appeal to an authority is not a logical fallacy if the people that are actually you're referring to are actual authorities. An appeal to an authority relates to people to claiming somebody is an authority when they're not an authority.
Okay, let's put that to one side.
Okay,
Let me challenge you with this idea. You've been very gracious to say that Bible believing scientists can be glad to have their view of the Creator and so forth.
Absolutely.
But let me challenge on another way of thinking about this. Let's go a different angle.
Great.
I think you and I both will agree that we don't know everything. We don't.
Agreed.
So let's draw a little memory aid that I've used with my students over the years, and let's talk about X, Y, and Z. So X is what you and I know. We both know that limestones consist of calcium carbonate. So we both can agree that that's something we know, right? That is a true statement. Now, we also, you and I both know, that there are things that we know are actually false. They're not true. It is simply not true that the Earth is flat. We have ample evidence that the Earth is a sphere from all the NASA work and so forth. So we have a group of things in our mind, the two of us, that we know are not true. But here's my challenge to you, my friend. The Z, the real problem in science is that we don't know what we don't know.
Yeah, of course.
And that's a critical thing, because
I agree.
Between now and Christmas, I'm not expecting you to change your mind in the 30 minutes we got left, but between now and Christmas, if I could provide you and you could provide me, look under this rock. Under this rock, we have clear-cut evidence that evolution never occurred and the Earth is young. And then you could say, no, McQueen, if we look here underneath this rock, we would see that uniformitarian processes are actually true. So will you at least admit, for the purposes of our debate, that you and I both don't know all that we do not know?
Sure. I totally agree with you.
Okay, the next topic I'd like to go to is your reliance on uniformitarianism.
And I'm going to jump in, gentlemen, as we get to the next topic, and let's say next question from Professor McQueen. Let's also make sure maybe it's a line of evidence for the flood that we'll have Dr. Torn engage, and then we're going to hand it to Jason to ask a few questions, and we'll kind of work that way. So
okay,
go ahead, David.
Good. Okay, I want to challenge, Jason, your contention about the Grand Canyon, and this is taken from my grandchildren. Here it is. Play-Doh from my grandchildren. And so my argument is that when the sediments in the lower part of the Grand Canyon were deposited, the limestones, the sandstones, the shale, they were soft. To use the rock mechanics vocabulary, they had a Young's modulus that indicated that they were soft and pliable. There's evidence in the Grand Canyon that has been presented on Standing for Truth over the last bit that shows that the deformation of some of the rocks in the Grand Canyon could not have been done when those rocks were rigid. What you've been taught, apparently, is you can start with something as rigid as a cell phone, and given enough time and pressure, you can fold that into an anticline or a syncline. What do you think
Well,
of that?
Well, that's established geologic science. I mean,
Is it?
Well, it's. I mean, I don't know. When you went to Michigan, did they teach you that?
Oh no, heavens no.
They didn't. They didn't
but
teach you that. With that, they didn't teach you that rock strata and deformation occur over very long periods of time with
I
heat and
misunderstood
temperature
you.
and pressure.
You're
Yeah. Okay.
At Tennessee and at Michigan, both
Okay.
those sets of professors were old Earth uniformitarian geologists.
And you think that all right, go ahead. Go ahead. Fine. Now I was going to say, and you think that all the pyramid of science that has supported, like those researchers who studied under other researchers and all of the papers that support all of these theories, they are wrong.
That's correct. And let me
okay? So if they're wrong, why? And you have a hypothesis as to them being wrong. Why not publish that work?
Okay, I'll use myself as an example.
Okay.
My master's thesis at Michigan dealt with rock mechanics, mineral deformation.
Okay.
I studied I studied a mineral called stibnite, and I was fortunate enough to get my paper published in an Elsevier journal in Europe called Tectonophysics, and I'll provide you with the exact reference to that. But I finished my master's in 79, so it's around that period of time. In the last paragraph of that paper, I point out some very unique deformation in stibnite. When I was called to be an expert witness in the 1982 Arkansas creation evolution trial, I presented this evidence to a group of geologists in Atlanta that had been hired by the ACLU. And they simply said, this is kind of like a tiny mystery, no big deal. So I would suggest that even I have published things that are consistent with flood geology. Now, Jason, I would challenge you on this point. Answer me. If I began my abstract for tectonophysics or the geological side of America or science by saying the Earth is 6,000 years old and I'm going to prove you, do you think that it would get through peer review?
If you had actual evidence to support that, then I think that it would be considered. Well, but you have to provide that. But you're going to have to provide your experimental research and reasons for that. You'd have to provide that.
I'm just asking for your response to the idea in climatology, for example. This would be a good topic for a debate in July or August. The whole idea of what do ice cores show us and VARVs and so forth. If I were to present in a climatological journal and send in a paper that suggested that I could get VARVs and ice really quite quick within hundreds of years, not thousands of years, would that be well received?
Again, it depends on if you're actually presenting novel research in that area. If your research isn't supportive of those topics, then it would likely not pass peer review.
Okay.
So, but I mean, your point is well taken. But what I'm saying is that if you're able to actually present cohesive research that supports your positions, the place to do that is in a peer-reviewed journal. And that's how you change the mindset of scientists. But if what you're claiming is if you presented this research and it would just get poo-pooed because those scientists have a biased view, then I think that falls into this conspiracy theory aspect of peer-reviewed science.
No, not at all. Not at all.
Okay.
No.
Well, I don't agree with that perspective. If that's the view.
Let me go to another.
But wait a second. You've been asking a lot of questions, so maybe I can.
I'm going to jump in here because I'm looking at the clock. So now we got 10 minutes left.
Maybe I can ask some questions.
Yeah,
exactly. So we'll give Jason 10 minutes
because I'm going to ask very specific questions of the flood. So, so I think my first question is a flood model dependent on a young Earth? In your view, do I need a young Earth or can I have an old Earth and a flood model?
No, the quick answer is because the worldwide flood is tied in to the historical record of Genesis, and the historical record of Genesis clearly portrays an Earth that's thousands of years old, not millions. It is required. It is linked.
Well, it's kind of an interesting thing that you mentioned. You mentioned Genesis and the Bible. So I don't quite understand how the Bible and Genesis have any reflection on whether the Earth is old or young. It's a book. It has writings in it. It has writings that say the donkey spoke and that the Red Sea was parted. There's a lot of things in it that you would probably say didn't happen. I mean, maybe you think that everything that happened in the Bible is true.
Well,
I mean, I don't know.
Let me respond to that.
Okay, please.
It is true that the Bible contains a number of topics, but the important topic for you and me tonight is the record of Genesis in regard to the worldwide flood, and it portrays the flood occurring over a 12-month period, not this Sunday school idea of 40 days and 40 nights. But in regard to the age of the Earth, I'd be interested to know how you would respond to a passage like Genesis 5:3. And Adam lived 130 years and had a son in his own likeness, called him Seth. And after the days of Adam, he had sons and daughters. And all the days that Adam lived were 930 years. Do you think there's any evidence that men of antiquity lived more than 120 years?
I don't know of any evidence that would suggest that people live 900 years old.
Okay, next question, my friend.
Yeah. So what caused the flood? So the flood, like scientifically, what is the cause of the flood?
Okay. The model that has been developed since after World War II by Dr. Henry Morris and others, going back to the 40s, is that there was a vapor canopy above the Earth. Now, Dr. Larry Vardaman and his graduate students have worked on the idea of 40 feet of evaporated water at a height of, say, 10,000 feet. And it's a very difficult model. Was it water vapor? Was it liquid water? People have been struggling with this for years. The Bible also talks about the fountains of the great deep breaking up. Now, if you go back to antiquity, most of the flood geologists in the 1700s thought of that as the movement of water up. But we now realize that it was lava and water. You can't dismiss the amount of water. It was a very interesting statistic you gave earlier about over 90% of the Earth's surface is, over 90% of the water in the Earth is in the ocean basins. No question that that's true now. And so the answer to your question is that there were conditions of the collapse of a canopy of some sort, probably not a vapor canopy, but a canopy of some sort. And so there was rain falling on the Earth, and there was catastrophic movement of lava and so forth. We are in the process. Baumgartner, you mentioned, is certainly someone who's worked on catastrophic plate tectonics, rapid movement of the plates.
Are you a proponent of that? Do you believe in catastrophic plate?
That's
you
correct.
are.
Yes.
Okay. Okay, that's interesting. Okay, so given the time, I want to give you opportunity to ask any remaining questions. But my last question is, like this proposed integrated model, like our Earth systems, we have a variety of different disciplines that all support an old Earth, and one that would suggest that it's not caused by like predominant catastrophic events. Do you see that there is an integrated model that can be constructed with regards to flood geology, a young Earth? Do you think that exists? And if it does exist, do you have any publications or work that might suggest that?
Yeah. I would start you off with Andrew Snelling's 2-volume work, this thing called Earth's Catastrophic Past.
Okay.
But let me address some of your areas of interest. You're interested in dendrochronology. You're interested in varves. You're interested in paleobotany, the origin of carbonates, mountain building, plate tectonics. What we as creation scientists have come to, especially since the year 2000, moving into the 21st century, is what we view as an integrated approach. I think there are legitimate problems with dendrochronology. I think there are legitimate problems as you would go to Greenland and actually drill down and measure the varves and so forth. The varves don't necessarily mean that there's 100,000 years worth of ice there in Greenland. So I believe there is an integrated approach. And by taking some of what your expertise is, I finished my career as a groundwater geologist, so groundwater, we could start with that. But we could, on another debate, deal with some of these very specific issues of varves and dendrochronology.
And I like that idea, David. And I think that like what you're touching upon, what we didn't have really time to talk about, but I think what could be an interesting discussion. And Donnie had mentioned this, like issues of like uniformitarianism versus changes in rapid rates of things, because obviously it's very difficult to be able to conclude that the amount of limestone, the amount of reformations, ice cores, varves could form under a scenario where we think that the rates, like, you know, your contention around the rates of decay have changed. So if your premise is that all of these things have changed in the past, that goes against much of what we know of modern science. And that could be an interesting point of discussion, is what evidence is there that things in currently are what they were in the past? And because I think that would support your position more if you could say, we know, we think we have evidence that things in the past have changed radically than what they are now. If you could, so that's an interesting topic to talk about.
During my 5-minute summary, I'm going to go back to this X, Y, and Z and give you a suggestion of how you're wrong about one particular point. Well, let me turn it back over to Donnie now.
Sure.
Gents, time is flying by, and this has been a fantastic exchange. As I predicted, very sophisticated. And since time's flying by, given how deep topics like this are, we should definitely set up a round two at some point in the next few months. And at this point, move into the closing statements. This has really been awesome, and I appreciate how respectful it's been.
Jason and I want to tip our hats to the audience. So why don't you give me one question and give him one question that have come in from the Standing for Truth audience. Out of kindness to Jason, you can start and go first.
Actually, you know what? I think given the time constraints, why don't we change up the format from what we usually do? Let's do like a couple questions each, then wrap it up with 2 closing statements, and then boom, we'll be able to end it right at 5 PST for Dr. Torn. Okay, well, we had some good questions that came in, so let's do this question from Andrew Cumming. And this is a good, I'll get the most relevant on topic questions that we can deal with. Maybe let's limit the responses to 2 minutes, and then 1 minute as a final word for the person who got the question. That way we can at least get a couple in. So this one comes in from Andrew Cumming, and he says, question for Jason. What are your thoughts about the fossil record and the sequential order of fossils in relation to a global flood? And he says if this topic's not brought up, and you guys didn't really discuss that specifically, so go ahead.
Yeah, I think that's a good topic. I did mention just briefly about fossil stratification, and certainly this is a bone of contention with regards to this discussion with folks who believe that of a global flood, of young Earth creationism. Modern geology is that the structure of fossils that we see have direct relationships to ecosystems and known processes that we see throughout the geologic rock record. We see marine environments where we can construct a history of formations of rocks, and that we can then evaluate, look at the fossils, look at how that matches up with what we know about those regimes. And we corroborate that information with other bits of information, with radiometric dating, with paleomagnetism, with paleogeography. So fossil stratification is an important, I think, point and supporting factor of an old Earth. I think I had mentioned issues of drag coefficients of a global flood that is kind of turbid, that is mixing up all these fossils that are of the same time period and then depositing them, wouldn't deposit in the manner that we see as part of the rock record. And so I think that's a major problem. And I know that Michael Ord on your channel has talked about some of his hypotheses around the flood only raised up a certain amount, and the animals that were at that level got picked up and deposited, and then it rose more and it picked up animals and got deposited. I think that that's this approach of trying to fit hypotheses to a known outcome. I think if we look just purely at what the rock record shows us, it shows stratified fossils that represent long periods of time, differing ecosystems, different regimes, and that's reflected in other disciplines as well.
Well, thank you very much for that answer there, Dr. Torn. And Professor McQueen, we'll give you now 2 minutes, and then Jason 1 minute for a final word.
Good.
Go ahead.
I want to challenge Jason and suggest he's wrong on the issue of fossil stratification. When you actually go to the Mississippi Gulf Coast and you look at the gastropods and pelecypods, the clams and the snail shells that are there, you find the shells, and they're often disarticulated on the beach, obviously. Would it not take a catastrophic event, at least locally in your way of thinking, to preserve a pelecypod that's closed or a brachiopod that's closed? I would suggest that all fossilization that we know of has to be a rapid event. I presume that over the years you've been to natural history museums like the Smithsonian and maybe the one in New York City or Chicago, and you've seen fish within fish. You've seen remarkably preserved dinosaur remains. When's the last time a dog died in your neighborhood, my friend, and was actually fossilized? They mostly just rot as roadkill where I live. What do you think?
Okay, thank you, Professor McQueen, for that response. And we'll give Jason the last minute. Go ahead, Jason.
Yeah, well, I would respectfully say that I didn't really hear a response to the topic of fossil stratification. We see very complicated structures throughout the rock record that represent sedimentary structures that have fossils in them, that we have very unique carbonate geography along marine areas. We have very unique, in the Grand Canyon, we have very unique structures that represent differing changes in ecosystems, changes in geology, and that have specific fossils that are not like hydrologically representative of a global flood. It doesn't mean that there aren't catastrophic events that do happen. It's just that the rock record doesn't represent, in my view, a global flood. And I think that my position, while you may consider this an appeal to an authority, it is my position is the same position that is represented by essentially 99% of all other geologists. And I think rightly so, because that evidence that we are talking about supports our position. And if there are other positions that support an alternative, I would say publish that work. And until that work is published, I'm not going to concur with that. So.
Well, thank you for the responses there, gents. Next one comes in the form of a super chat. And George Bond, I appreciate the $10 super chat. Question for JT. So that'd be you, Jason Torn. Can recumbent folds form by Aeolian processes, hopefully I said that right, as in the Coconino sandstone?
Okay, that's a good question. Well, in situ processes, typically not. So we see in the initial formations of sandstones, particular lee side representations. We see very long wave structures that are representative of sandstones of aeolian processes. But once lithified, we can get folds of sedimentary features. So the question, I think, doesn't address or considers that there's not these long-term processes which can cause structural changes after lithification. And so that would be my answer. And I'm sure David's got a different perspective. I'm curious what he thinks.
Sure. Thank you very much, Jason. Over to you, David.
Okay, let's make sure Jason and the rest of the audience understands George's comment about recumbent folds. Imagine this to be this soft rock of the Coconino sandstones. A recumbent fold is one where the I wish this didn't have those different colors there. Let me do it this way. It's where it's completely folded over and down. It's not simply an anticline, simply a syncline. It's completely recumbent or over on itself. This, Jason, is to me a clear argument that the Coconino was soft, the same rock mechanics as Plato during its formation. Now, you and I both know, Jason, that there are amphibian and reptile footprints in the Coconino sandstone. One of my former graduate students has done quite a bit of work there in the Grand Canyon. I myself have seen these footprints. I've seen these footprints 5 times when I've hiked the canyon. But I've noticed a very interesting data point, Jason. I'm curious to know what you think. You find the footprints, but you don't find the fossils that made the footprints. It's almost as if a catastrophic event was rising, and as these creatures, I'll use my marker here, made an indention as they were running away from this. They made the footprints, rapidly covered, buried in the Coconino sandstone. What do you make of the fact that you don't find the reptile amphibians in the same layer as the footprints?
Thank you, David. And Jason, question was for you. Get the final word.
Yeah, I don't see a problem with that. I mean, I don't see a problem with us finding trace fossils and not the fossils themselves. We find this extensively. I think that there are reasonable explanations for that. Actually, I think that this refutes your position, because if it was a catastrophic flood and there were animals walking and creating footprints, wouldn't a global flood have deposited those animals right at that moment? Or in close proximity? Why aren't they deposited there? I mean, and I don't think that the issue of recumbent folds, I think that that's not a problem with regards to a lithified structure. I mean, if the argument is that rocks can't be structurally deformed once they have been lithified, is against so much research. I don't even know where to begin. Well,
Jason,
we could go through the structural geology math on that, but I mean, I think that it's very well known that can happen with time and pressure.
Well, Jason, we obviously have much to talk about, but we're down to our last 10 minutes here, and who will close first, Donnie?
And that's what I was going to say. So I want to respect the agreed upon time. It's very interesting how quickly 2 hours goes by when you have two, well-studied scientists like yourself engaging this important topic. So let's jump into some concluding statements, and that gives us 5 minutes each to wrap up our thoughts and address any points that may have been left hanging. So Professor McQueen, since you are the affirmative tonight, we'll give you the first 5 minutes. And then we'll give Dr. Torn the final 5 minutes. So go ahead whenever you're ready, David.
Okay. The issue that I come back to over and over again is, as a Christian who happened to choose geology as my profession, the argument that I give that the Bible is a trustworthy historical document is critical. As you go from the Old Testament to New Testament, Jesus, everybody referred back to the creation of Adam and Eve and the flood and all the details of that. And if you continue to go over to Paul's writings and you get over to the First Peter and Second Peter, you run into an interesting argument that I'll close with. In 2 Peter 3, verse 1, it says, "This second epistle, beloved, which now I write to you, both of them have been tried to stir up your pure minds by remembrance." This is King James, basically. "That you would be mindful of the words spoken by the prophets." Now, wait, I went over something too quickly. I stir up your pure mind. That's the goal that Jason and I have, I think. We want to have a pure mind as we approach Earth history, the flood, radiometric dating, and so forth. And in my closing statement, Jason, I want to go back to this XYZ argument that I've used with the students over the years. We both agree that we know certain things. Chemistry of limestone, for example. We both agree that there are certain things that we either know are false or that we don't know. This whole ridiculous argument that the earth is flat instead of a sphere, one example. But I want to focus in on the third part. It's said in kind of a conundrum, I do not know what I do not know. So how do I resolve that as a Christian creationist, young earth creation? I resolve it in the concept of imperfect knowledge. I will turn 70 in a couple of months. The best geologist is the one that's seen the most rocks. I haven't seen them all. But if I accept the Bible as a historical document where God has revealed to us what we otherwise could not know, then I've got a little bit of a good argument, I think, revolving around imperfect knowledge. What I don't know about the age of the earth, what I don't know about how long Adam lived and others that lived 900 years, the Bible will show me. Is the Bible a book of science? No. It's a book of historical accuracy. When it talks about science, it talks with authority. Very much enjoyed this, Jason. We'll have to return to some of these topics. I think you're clearly wrong on some of these things. You apparently think I'm clearly wrong on some of these things. And so if we agree to study from now till Christmas, who knows whose mind will be changed.
Thank you very much, David McQueen, for that 5-minute closing statement. Jason, we're going to hand it over to you, and you've got up to 5 minutes as well for a concluding statement.
Great. Well, thank you very much, David. I think this has been a really fun debate. I really appreciate being on the channel, Donnie. I would start off my closing remarks by just reemphasizing what I had said previously, which is on the two topics of the age of the earth and of the global flood model, that the variety of disciplines and topics that I mentioned, plate tectonics, dendrochronology, ice cores, varves, sedimentology, glaciology. We could go down the list of different areas that I didn't cover. Extinction events, a variety of different areas. I didn't talk about distant starlight. I didn't talk about a number of topics that all support a position of an old Earth, and also support a position of primarily uniformitarianism. Doesn't mean that catastrophicism doesn't occur, but that slow, gradual processes are the predominant mechanism for what we see in the rock record. Yes, I think that David is wrong on these topics. I respect David's opinion, but I think that he's got his facts wrong. And I think that what he's done, as per his closing remarks, is that he has a religious conviction as to what he sees in the Bible, and that he's letting that form his views as to what information he's going to use to support that hypothesis. As a scientist, I am absolutely willing to acknowledge that we do not know everything, and that there are many things that we don't know, and we don't know what we don't know. But science is the best method that we have for exploring our world. And all scientists acknowledge that oftentimes we are not absolutely certain about anything. And we're constantly trying to zero in on the bullseye of what we think is actually going on with our world. I think that we have done course correction on this over many hundreds of years, to course correct to get closer and closer to what we know about the age of the Earth, to what we do and understand about the Earth's global processes. And the interesting thing is that our current understandings of all these disciplines all corroborate one another. And until such a time as that creationists can form a coherent model that identifies those areas that can support a position and can publish that work and change scientists' minds, then I am going to stick with what the consensus is at this moment. I'm certainly willing to change my mind, but I think that is going to require extraordinary amount of research to be published in that area. However, I would just end on, I would be very happy to have further discussions with David on these topics. And if David can convince me through research and information to change my mind, I'm willing to do that. I want to be an objective scientist, and I want to be willing to change my mind. So I look forward to opportunity to talk more with David. And I'm, again, absolutely willing to listen to his perspectives and to be willing to change my mind. And I thank everybody for having me on.
Well, I thank you, Dr. Torn, for that 5-minute concluding statement. Again, fantastic debate, gentlemen. Clearly, you both prepped a lot for this, and it really showed. It was a very good debate. Any final words, final thoughts from the both of you? I do want to say again, thank you so much for giving us your time for this, and I look forward to a round 2 debate between you two.
The only concern I have, Jason, is what if you were to convince me to start drinking tea instead of coffee? I mean, that would be a paradigm change for me. It's very difficult in southern United States to do that, my friend.
You would be a better person for it, but
I'm sure I would. Maybe
I'll wear a bow tie for my next one. So
over the next month, I will send you via your email address the references to Gentry's work and others. Oh. I really do assure you that they were peer reviewed by science and nature and so forth. So I thank you, Donnie, for keeping us on track here.
Yeah.
Thank you, Jason.
Yeah. Thanks to both you guys. I think there was a really respectful debate, and I enjoy having these kinds of discussions. The reason I wanted to do the debate with David is because his reputation precedes himself as being a respectful debater and being a good person. And so I think that comes across in your discussions, and I really enjoyed the chat.
Well, that's kind of you, Jason. I'll call Ms. McQueen in. After 50 years of marriage, she has a viewpoint about how good a person I am. We'll let you take the compliment.
Same with my wife. Yeah. So same thing. So
I hear you. Well said. Great final words and final thoughts. Again, thank you so much for doing this and making this a debate to remember. We'll let you gentlemen get out of here. And to the live chat, thank you so much for tuning in. Standing for Truth is out. Have a great night.